Today I am discussing brute force design technique. Brute force design technique uh, is directly based on problem statement and definitions of the concepts involved. For example, if you want to find a power n, when a is greater than 0 and n is non-negative integer, we are required to multiply a n times. Similarly, finding factorial of a number is also an example for brute force. Multiplying two matrices is another example, or searching a key for a given list of elements. And these are the examples for brute force design technique. Now we will see sorting algorithm, that too selection sort algorithm. So in selection sort algorithm, the idea behind here is, in the first iteration, the minimum element is searched and kept in the appropriate position, and in the second iteration, next smallest element is found and kept in the second location. For that, algorithm goes like this: vary the I from 0 to n minus 2, set minimum to I. For j equal to I plus 1 to n minus 1, you are required to perform this. If a of I is less than a of min, set minimum to j. Swap ai and a min. To trace this algorithm, I have taken this example here. There are 5 elements, n value is 5, a0, a1, a2 is 50, a3 is 40 and a4 is 10 here. So as it is in the algorithm, you have to set minimum to I. So therefore minimum equal to I, that is minimum equal to 0. So a of 0 is 20. Now this element is to be compared with remaining all the elements of the array. For that reason, you are required to perform the inner loop from I plus 1 to n minus 1. So now 20 is compared with 30. So since aj is not less than a of min, no change. Here also there is no change. Here you are finding the element less than a min, so set minimum to this index. Now minimum equal to j, that is minimum equal to 4. Now a4 is swapped with a0. After the completion of the first iteration, minimum is placed in the first location. This is the resultant array after the completion of the first iteration. Similarly, you are required to do for the second iteration. So when you do like that, second smallest is kept in the second position. So here, finally I is to be varied from 0 to n minus 2, that is 5 minus 2 is 3. So after the completion of this iteration, you can find the sorted array. In order to sort these elements, so in the first iteration 4 comparison, second 3, third iteration, that is I equal to 2 comparison, when I equal to 3, 1 comparison, total number of comparison is 10. This is nothing but sum of natural number up to 4, 1 to 4. That is, now there are 5 elements. So when there are 5 elements, then in the first iteration 4, second 3, third 2, then finally 1 comparison. In general, if there are n elements in the array, in the first iteration n minus 1 comparison, in the second n minus 2, in the third n minus 3, finally 1 comparison. So it's nothing but sum of natural number up to n minus 1, it's equal to n into n minus 1 by 2. That we'll see with the algorithm analysis. Compare. Now in this comparison is the basic operation performed in this algorithm. Outer loop I is varied from 0 to n minus 2 and the inner loop is varied from I plus 1 to n minus 1. Therefore, this is the analysis part. So inner summation n minus 1 minus I plus 1 plus 1, that is upper limit minus lower limit plus 1. So once you simplify all these things, the final answer what you are going to get is n into n minus 1 divided by 2. This belongs to theta of n square. Next we'll see another example for brute force bubble sort. In this algorithm, the element is compared with the adjacent element. So in case like you know the order of the elements here. So what is the order? A0 must be less than or equal to A1, A1 must be less than or equal to A2, so on. In case A0 is not less than A1, then these two is to be swapped. So that is how you are performing here. Aj plus 1, that is Aj is supposed to be less than Aj plus 1, but Aj is greater than Aj plus 1. If that is the case, you have to swap Aj with Aj plus 1. This is to be done like for I equal to 0 to n minus 2 and for j equal to 0 to n minus 2 minus I. So after the completion of the first iteration, the largest element is bubbled out to the last location. Now take this example here. 89 is compared with 45. Actually this A0 must be less than A1, but it's not like that. So you have to swap. So when you swap, the elements look like this. Again 89 with 68. So A1 is not less than A2. These two is swapped. Again 68 and 90. These two are in the order. No swapping is being done. Then 90 with 29. So this is not in the order. So you need to swap 29 and 90. Then again 90 is to be compared with 34. 34 is less, so interchange these elements. So finally 90 with 17. So since 17 is less, you have to interchange. Look at here. After the completion of the first iteration, the largest element is bubbled out to the last location. Similarly, after the completion of the second iteration, 89, second largest is bubbled out to the last but one location. Now we'll see the analysis. That you know, like this is to be done from I equal to 0 to n minus 2. That is totally n minus 1 iterations you are required to carry out. We'll see the analysis part of this. Here for every iteration, comparison is the basic operation you are performing here. So you need to count how many comparison is being made in this algorithm. For that, I is varied from 0 to n minus 2 and j from 0 to n minus 2 minus I. So the same thing is written here. When you simplify the inner summation, you are getting n minus 2 minus I, upper limit minus lower limit plus 1. So simplified answer is n minus 1 minus I. Next, here I is taking the values from 0 to n minus 2. Substitute that values here. So this is again n minus 1 plus n minus 2 plus n minus 3, so on. n minus 1 minus of n minus 2 is nothing but 1. So 1 plus 2 plus 3, so on up to n minus 1. Final answer, that is sum of natural number up to n minus 1 terms, is n into n minus 1 by 2. So this belongs to theta of n square. Thank you.